Hi guys, welcome to the lesson of partial differential equations. The topic of our discussion today is the maximum and minimum principle. So in our previous lesson, we talk about maximum and minimum. Now we will take some problems and we will see how to solve the problems for maximum and minimum values of partial differential equations. So question number one is show that the solution uxt is in the range of uh, 0 to 2.25, right? So for the given heat equation, we have to find that we have to show that in fact that the solution lies in this range, and this 0 represents the minimum value and this 2.25 represents the maximum value. So we can circle it with green, the maximum, and we can circle the minimum with blue, right? So now we will approach to the problem and we will see how to approach this problem. The question is given, a heat equation is given. We can say it equation number one, and then the boundary conditions are given. In fact, these are homogeneous Newman boundary conditions. We can see that these are derivative boundary conditions, so these are Newman conditions, and the conditions are equals to 0 at boundaries, so these are homogeneous Newman boundary conditions, right? Homogeneous Newman boundary conditions. And then the initial condition is given, that is at time t is equals to 0, the behavior of heat in the material is given by this function 1.5 minus cosine x minus 0.5 cosine 2x, right? So first of all, to find the maximum value, we know from the calculus that we need to find the derivative, the first derivative, that is basically the slope, and where the slope is equals to 0, then the case is either maximum or minimum, right? So we need to find the derivative of this given initial condition. So we will differentiate this cosine x, we will get positive sine x because of this negative sign, and then negative 0.5 times cosine 2x will be sine 2x, right? So for maximum or minimum, we need to equate this with 0, and then we will find the values of x in terms of pi. So here it's sine 2x and sine x. So we can uh, write 2 sine x cosine x instead of sine 2x, because it's a trigonometric identity. So sine x plus 2 sine x cosine x is equals to 0. Then you will take sine as a common from both elements, and then you'll get sine x times 1 plus 2 cosine x is equals to 0. So we will equate either sine x is equals to 0 and then 1 plus 2 cosine x is equals to 0. From here we will get x is equals to sine inverse 0, which is either 0 or pi, right? Because we know that sine 0 is 0 and then sine pi is also 0, right? So we'll consider both 0 and pi, because we know that x is in the range of 0 and pi, right? So we will consider both 0 and pi. Then this thing is all right, you can see from the boundary conditions that boundary conditions are from 0 to pi. That's why we are including both 0 and pi, right? So now from this equation, cosine from this one, 1 plus 2 cosine x is equals to 0. We'll solve this for x, and we'll get x is equals to 2 pi over 3, right? So we got three values, that is 0, pi, and 2 pi over 3. Now we will plug these values in the initial condition, to get the minimum and maximum. So first of all, we will apply 0. So u of 0, 0 is equals to 1.5 minus cosine 0 minus 0.5 times cosine 0. So we'll get 0 here, right? After solving the equation, we get 0. So we can say that this is 1, right? Then we will apply pi. So u of pi comma 0 is equals to 1.5 minus cos pi minus 0.5 cosine 2 pi, right? So from here, this is 1.5, and then cosine pi is -1, negative 0.5, and cosine 2 pi is 1. So it will be, we will get 2 here, right? So 2 here. So this we can call as 2. Now we will check for 3 pi over 2 pi over 3. So u of 2 pi over 3 is equals 1.5 times cosine 2 pi over 3 minus 0.5 times cosine 2 times 2 pi over 3. So this will be cosine 4 pi over 3, right? Which is equals to -1 over 2. So we'll plug the value here and plug the value of 2 pi over 3 here. So we'll simplify this equation and we will get 2.25. And so in this manner, we can see that u of 0, 0 is 0, u of pi comma 0 is 2, and u of 2 pi over 3 comma 0 is 2.25. So we can see that this is the maximum value and this is the minimum value, and this was the objective of this problem, that we have to show that the value of ux comma t is in between 0 and 2.25, right? So we are done with this problem. Now we'll move to the problem number 2. That is another heat equation. Find the maximum and minimum values of the solution of following heat equation, right? So this is the heat equation. Say this is 1. And then the boundary conditions are Dirichlet boundary conditions, because these are non-derivative boundary conditions. So these are Dirichlet boundary conditions. Dirichlet boundary conditions, right? And these are non-homogeneous boundary conditions, right? Because we can see that on the right hand side we have constant values. So these are non-homogeneous Dirichlet boundary conditions. Right, so now the initial condition at time t is equals to 0. This is basically at time t is equals to 0 is given as 1 minus 4 sine 3x over 2. Now again, for calculation of maximum and minimum, we know that we have to find the derivative. So we will differentiate dou ux comma 0 with respect to x, and we will get this -4 times 3 over 2 times cosine 3x over 2, right? So we'll simplify this. This will be cancelled, and -2 times 3 is equals to -6 times cosine 3x over 2 is equals to 0, right? So from here, cosine 3x over 2 is equals to 0. It means that 3x over 2 is equals to cosine of 0, cosine inverse of 0, right? So now cosine inverse 0 gives us two values, that is pi over 2 and 3 pi over 2 respectively, because cos pi over 2 is also 0 and cos 3 pi over 2 is also 0, right? And then we will solve for x, and on simplifying this condition we get to pi over 3, and simplifying this condition we get to pi, and uh, we are now we can now see that in the question initially the conditions the limits are from 0 to pi, right? So pi over 3 and pi, both values are good in our range. So we will calculate the initial condition with both of these values separately. First of all, we'll check at x is equals to pi over 3. So we will plug in the initial condition. This is our initial condition. So we will plug pi over 3 in the condition, and we will get 1 minus 4 sine 3 times pi over 3 times 2. So this 3 and 3 will cancel out. This 3 and this 3 will left with pi over 2 in the bracket. So sine pi over 2 is 1. Therefore, sine pi 2 is equals to 1. Therefore, it will be 1 minus negative 4. Sorry, 1 minus 4. So we will get negative 3, right? So u of pi over 3 comma 0 is negative 3. Then we will calculate for u of pi comma 0. We will plug pi instead of x here. So we will get 1 minus 4 times negative 1, because sine 3 pi over 2 is equals to negative 1. All right, so in this manner, we'll solve and we'll get u of pi comma 0 is equals to 5. So we got two values, that is u of pi over 3 is equals to 0 is equals to negative 3, and u of pi comma 0 is equals to 5, right? So now we can see that this is the minimum negative 3 and this is the maximum value. So we can say that the solution will be in the range of negative 3 and 5, right? This is the minimum value for the solution of the seat equation, and this will be the maximum value, right? Now let's move to the third question. So basically this is a Laplace equation in Cartesian coordinates. It says that suppose the function u of xy is equals to 1 plus x minus y whole squared. This function is the solution of given Laplace equation, right? So Laplace equation is given here, uxx plus uyy is equals to 0. And the conditions are x squared plus y squared less than 1. And for the solution, the condition is x squared plus y squared is equals to 1, right? So find the question says find the maximum and minimum values in the closed disk x comma y comma x squared plus y squared is less than equals to 1. So here we can see that radius is given as 1. So now we can convert this Cartesian form to the polar form very easily by using x is equals to r cosine theta and y is equals to r sine theta, right? So it will be easier to find the maximum and minimum using these polar coordinates. So now when we will apply this r cos theta and r sine theta in the solution, what we will get is, first of all, we open the bracket using the formula, and now we will apply the values of x and y, that is r cos theta, r sine theta. So we can convert the equation from Cartesian coordinate to polar coordinates, and here we just replace this x with r cos theta, and here with r cos theta, r sine theta, and here with r sine theta, right? So we get 1 plus cosine square theta plus sine square theta, because this r is equals to 1, and it's given in the question that a closed disk of radius 1. From here we can see that r is equals to 1, right? This is basically the equation of disk. And so r is equals to 1. So cosine square theta plus sine square theta, this will make it 1. And 1 plus 1, we will get 2 minus 2 sine theta cos theta. And again, 2 sine theta cos theta is equals to sine 2 theta. So we can write here is equals to sine 2 theta, right? So 2 minus sine 2 theta, and then we get the polar coordinate. We get the solution in the polar coordinates, polar form, that is 2 minus sine 2 theta. So u r theta, now ux y is converted to u r theta, right? So now u r theta is equals to 2 minus sine 2 theta, and now again I will apply that condition to find the maximum and minimum. We will find the derivative and equate it to 0. So the derivative of 2 will be 0, and then the derivative of sine 2 theta will be 2 cos 2 theta. Now we know that the derivative should be equals to 0 for finding the maxima minima. So cosine 2 theta is equals to 0, 2 theta is equals to cosine inverse 0. Again, we get two values because we know that cosine inverse 0 is equals to pi over 2. Also, cosine inverse 0 is equals to 3 pi over 2, right? So from here, we can get the values of theta. So 2 theta is either equals to pi over 2 or 2 theta is equals to 3 pi over 2. From here, we will get two values of theta, that is pi over 4 and 3 pi over 4, right? So now we will plug the values of theta separately in the solution, that is theta is equals to pi over 4. So at theta is equals to pi over 4, u r comma pi over 4 is equals to 2 minus sine 2 times pi over 4. So 2 times pi over 4 will be pi over 2. This will be 1. So 2 minus 1 is equals to 1. Again, we will check for pi over 4. So pi over 4 is 1, sorry. Now we'll check for 3 pi over 4. So we'll plug in 3 pi over 4 instead of theta. So 2 times 3 pi over 4 means 3 pi over 2. Sine 3 pi over 2 is -1. So 2 minus -1 is equals to 3. So this is the value at 3 pi over 4. Now we can see that u of r comma pi over 4 is 1 and u of r comma 3 pi over 4 is 3. So here is the maximum and here is the minimum. So we can draw it on a disk. It is a basically disk. So we can draw it on the disk that at pi over 4, the minimum value, and at 3 pi over 4, we have the maximum value. So these were some solved problems for better understanding, and hope you guys will enjoy the video. Keep watching the videos, and if you like the videos, subscribe for following the videos, right? So thank you.